Hi, my name is Alex Maguffee. I'm a master's student working at the Quantitative Fisheries Center at Michigan State University. My research focuses on the movement of wild Chinook salmon between Lake Michigan and Lake Huron. Chinook salmon are Pacific salmonids that were introduced to the Great Lakes in the late 1960s to both establish a sport fishery and control the invasive species known as alewife. They are now one of the most sought-after fish in the Great Lakes, due in part to the challenge they provide to anglers, as well as their rapid growth rates. Now, since Chinook salmon were introduced, natural populations have established themselves in Lake Michigan and Lake Huron. In recent years, wild fish have contributed more to the population than stockfish. But despite this, most of the assessment of Chinook salmon stocks in the Great Lakes comes from the mark recapture studies of hatchery fish. And there's a particular need for the assessment of wild fish and their movement and contribution to the fishery, especially following the collapse of the alewife, their primary prey species, in Lake Huron in 2004. The reason this is important is that there has been evidence to suggest that Lake Huron-produced Chinook salmon migrate to Lake Michigan to forage, which has the potential to put pressure on the population numbers of prey fish in Lake Michigan. Now, we have ways to assess the contribution of wild versus hatchery fish to the fishery in Lake Michigan, but we've yet to assess the contribution of wild Lake Michigan versus wild Lake Huron Chinook salmon to the Lake Michigan fishery. Now, given the popularity of Chinook salmon, as well as the nearly $7 billion fishery in the Great Lakes, this is a definite research need. So one of the most common methods to assess wild fish, especially recently, is called otolith microchemistry. An otolith of fish, which is also called an earstone, is a calcified structure that incorporates trace elements from the environment. And these trace element concentrations can be differentiated between collection sites. Now, I've been able to use this method with a high degree of success, so it definitely has the potential to be used as a tool to assess the movement of wild fish between Lake Michigan and Lake Huron. And again, what we're really trying to get at is the contribution of wild Lake Huron Chinook salmon to the Lake Michigan recreational harvest. Now, where does this fit in from a policy standpoint? Mostly it has to do with how we hope this work will influence management decisions, in particular stocking rates. And again, what we're really trying to get at is the contribution of wild Lake Huron Chinook salmon to the Lake Michigan recreational harvest. Now, where does this fit in from a policy standpoint? Mostly it has to do with how we hope this work will influence management. We hope to provide this tool to managers in hopes that they will make more informed decisions regarding Great Lakes Chinook salmon, in particular decisions on stocking rates. That way we can answer questions such as how many fish, both wild and hatchery reared, are migrating to Lake Michigan to feed. Another question might be, does the contribution of wild Lake Huron fish to the Lake Michigan fishery vary spatially and seasonally? And another question would be, should we be treating Lake Michigan and Lake Huron as separate lakes from a management standpoint in regards to stocking, or should we treat them as one when we're making these decisions? So hopefully we'll be able to answer these questions and to help protect Chinook salmon for this generation and for future generations as well. And that's all. Thanks for listening.